Okay, so your homework assignment as part of the study guide for Monday, just to clarify, is to really try and understand these pre-response problems and these pre-response topics. What I'm doing here, if you want to, basically you have to attempt 4 free response problems which follow these topics. And the key is already attached to the same file. And what I want you to do is like try them and then compare your results to the actual value, like the actual key answer, and then correct your work, but showing what you actually changed in the beginning. And you can do that if you want to, either by adding a comment or by using the suggesting function. To change to the suggesting function, do what I'm doing here and go to where it says editing mode in the top right-hand corner and click suggesting. And then it'll leave your old code, but you can like hit backspace and it'll strike it out and you'll like replace components of it there so that you can actually see what your most common mistakes are as you do this. Again, this is a video version of the solutions where I'm going to go a little bit more in depth than I did for the original components. It'll probably end up being a couple of videos tied together. So I'm just giving you a heads up on that now because I'm going to talk through a little bit of what the free response format looks like and maybe give some tips for how to think about this problem, each of these problems as you take a look at them. In my opinion, we've kind of learned how to solve 4 types of coding problems this semester and write actual free response code too. We've learned how to perform basic calculations, average, add, modulus, calculate some sort of math equation, all that good stuff. We've learned how to manipulate strings. And I think the most interesting way of doing this is using the substring function. How can we actually take chunks of strings and split them apart? We've used for loops to manipulate or read information from strings. This references mastery assignment number 4 here. For example, like the take all the vowels out of the string problem that you did. And then we've learned how to like search, process, and manipulate int, double, and string arrays, which is what the mastery assignment you just finished up was about. You were calculating an average of an array. You were calculating the average length of the words in an array. You were searching through an array for a particular piece of information, like a keyword. Okay, that's exactly what we're getting at here. So just so that you understand this format, on your final, you will not get the exact same questions as follows, but you'll get things that look like these questions. And in my opinion, they should like take about, so like probably 2 or 3 of these. So I would feel comfortable with the solutions to these and understand the big ideas and be comfortable with doing something like this for each of your free response problems on the exam. So let's kind of get started on what these actually might look like. I'm just going to copy and paste these problems into a new workspace. I'll probably get through solution number 1 in this video. But also leave some space to describe why things are occurring and kind of ask you some questions to think about as you go. So the first problem says a method called getAverage takes in 3 integer parameters. It creates a double that represents the average of the 3 integers as accurately as possible. And the other kind of weird thing about this one is that if we assume the integers are percents originally, we want to return a decimal instead. So we want to turn 95%, say if that were the average, into a 0.95. So you can think a little bit as you work about how you might do that for a math class. Now, all of the problems that you're going to be given on the final and on the AP exam are in the format of methods, because methods are a way of automating our code. It's pretty common to get a method header that's already written. And if you look at problem number 2, they've written the method header for you for that one. But it's really like about, but occasionally they might ask you to write a method header yourself. And so for this problem of the 4, this is the only one where I'm asking you to write a method header. So there's kind of 2 parts to this problem. How do we write the header? And how do we actually do the calculations here? So when it comes to headers, the advice I'm going to give you is what goes in, what goes out. That's what you need to think about and highlight as you look through this today. All methods take in information. And we call these parameters. I'm going to leave that in blue for now. That's what a method, like it'll take in some specific type of information or some type of variables, and it'll run it through the method. In this case, average is, or get average is the name of our method. And then it creates something. It returns something. Basically what this creates. So this is how you have to think about writing a method header. The first thing that you're going to want to do is think, what does it take in? Read the problem, think about what it takes in. If you need to highlight it, do it. And if I look pretty closely, you can see that this problem takes in 3 integer parameters. I've highlighted that blue to go with our theory of a method taking in something. And it creates a double. So when we're actually writing this code, our header always takes the format of the word public, followed by the return type, which is our fancy word for what is created, followed by the name, and then our parameters, which are the types of information this takes in that need to go here. And you're specifying what types those are. So I'm going to write the method header for this thing. Public. The name of the method, or the return type of this, is it creates a double. So I'm sending a double back. Get average. Int A, int B, int C. And now the reason that I'm writing this is because I've specified that each of these is an integer that it's expecting. It's expecting 3 integers, and it's going to take the average of them as a double. So now you've written our method. And if you go back to your 5.1 notes, if you want to check it out, for every single problem you write on the final, I give you 3 steps to write a method. 3 things that you need to do. 3 things you need to do to create the method. If you want to go back and check your notes, but we're going to apply this for every single one that you do. The first thing that you do, this is my always first step to write a method, is to create a variable of the return type. Then you'll perform the operation that's given to you. And then you'll return the variable at the end. If you're having trouble knowing how to break down method problems, this is the format. These are the steps that you need to follow for every single one. Create a variable of the return type. Perform the operation. Return the variable. So let's start with the easy parts of this. I need a variable of the return type. Double. Double is going to be my result. I'm just going to start with double X up here for fun. And I got to return it at the end. So I'll return X. X is going to represent the result of the operation that we're performing. Now, in this case, I want you to think and look at the structure of the problem yourself. When you're thinking about performing the operation, you're asking, what should this method actually do? What should this method actually do? I'm going to argue that there are 2 things that this method is going to do. See if you can find them by yourself. Pause the video if it's helpful to think about. In my opinion, the method needs to take the average of the 3 numbers, convert the percentage to the decimal. If we're assuming these are percents, we can just kind of assume A, B, C are between we know that they're percents, right? They're whole values that way. So double X. Remember the first thing we said we wanted to do was take the average. This is something you've done a million times. A plus B plus C divided by 3. That'll take the average of the 3 of them. But you might have noticed that these 3 are integers. This is an integer also. This is one of the most common errors that we have, is that dividing 2 integers will give you an integer and not a double. And it won't preserve the accuracy of it. Remember our 3.5 to 3.0 problem we've done a million times. So the 2 ways to fix that are to either write 0.0 here. When it divides an integer by a double, it'll turn it into a double. Or I kind of like to remind myself that if I cast it as a double, the resulting information will keep its decimal point. Next, I need to convert the percentage to a decimal. I mentioned that X is going to represent a decimal number here, or a percent number here. If maybe I average 93, 95, 97, and I get 95.0, I want to turn that into a decimal just by the specification of this problem. Think to yourself in math class, how do you turn a percentage into a decimal? Pause the video if you need to. Think about it for a sec. In my opinion, all you have to do is divide by 100. Think to yourself about the code that we have to divide a variable by 100 and save it back into itself. In my opinion, the easiest way to write that code is X equals X divided by 100. That means take the current value of X divided by 100 and save it back into X. If you forgot what these lines of code were representing. But another way to do that is also X divided equals 100, just like we use that plus equals function or whatever. Okay, that's the big idea for how this one works. It's really only 4 lines of code, but there's a lot of comments. Define the header, create a double that's the average of the 3 ints divided by 100, and return it. If you want to keep going, the next video will go over some of the future problems.